All right, so this first page, we're just going to put the name of the rule, the formula. I'm not going to do an example. If you want to go back through your notes and find an example so that you have one next to it, you can. And then we're going to make some notes about when to use them. Mainly, I'm going to give you some key words, which are then going to help us fill out this graphic organizer. And like I said, hopefully it'll help clarify so that you know which rules to use and when. So our first rule that we learned was the complement rule. And I'm going to tell you right now, my handwriting's too big. Even when I know to write small, I did fit it in that time. I'm not going to be able to stay in the boxes. I write too big. So our complement rule is that the probability of a complement comes from 1 minus the probability of A. That was our first rule that we learned. And then the next rule we learned was the addition rule for mutually exclusive events. And that told us that I wanted to use a different color. The probability of A or B is found by taking the probability of A plus the probability of B. And just as a reminder, mutually exclusive events are events that cannot occur at the same time. So an example would be my favorite deck of cards. If event A is the card I pick is red and event B is the card I pick is black, those two events cannot happen at the same time. So they would be mutually exclusive. And then, of course, we learned, well, not everything's mutually exclusive. What if event A is a red card and event B is picking a card that says 6? Those aren't mutually exclusive, so we had to have an addition rule for any two events. And that addition rule told us that we would find the probability of A or B by taking the probability of A plus the probability of B and then subtracting their overlap. Because when we find the probability of A, we're counting the overlap, and when we find the probability of B, we're also counting the stuff in the overlap, so we have to subtract it so we don't count those things twice. Then we learned the conditional probability rule, And that told us the probability of B happening given A happened can be found by taking the probability of A and B and dividing by the probability of A. Then we manipulated that rule to help us find the general multiplication rule. And the general multiplication rule told us that the probability A and B happens can be found by taking the probability of B given A times the probability of A. And then we talked about, well, if A has no effect on B, the probability that A and B happens can be found using the multiplication rule for independent events. I was doing so good staying in the boxes, and the word independent came into play. So if A happening has no effect on the probability that B happens, our multiplication rule got a little simpler, and the probability of A and B happening is just the probability of B times the probability of A. And then yesterday, we talked about the last one, which technically, if you look, isn't its own rule, but it shows up often enough that I like to call it its own rule, and that was the at least one. So to find the probability that at least one happens, whatever you're looking at, you would take 1 minus the probability that none of it happens and raise it to your sample size. So yesterday we talked about the Mountain Dew, and the guy bought 5 bottles, so what's the probability that he wins on at least one? Well, we did 1 minus the probability. None of them are winners to the 5th power because it was 5 bottles. Then we talked about the first trimester pregnancy test, and so there were 100 women in that study, so we raised it to the 100th power. And then the last one was the HIV rapid test, and there were 200 people in that sample size, so we raised it to the 200th power. So when I put n, that's whatever your sample size is. Any questions before we move on to the graphic organizer? Hopefully the graphic organizer, I'm going to say we're going to bounce back and forth, but we're not. We're going to fill out the graphic organizer, and then we'll come back and make some notes. And like I said, the example column, I'm going to leave that up to you. You want to add examples, add them, but you don't have to. So now we're going to look here. And I'm going to call this, sorry, I wanted to come up with some really dorky name like Amber's world of probability, but no, we're not doing that. We're just going to call this probability keywords and the words that we should look for to tell us which rule. Probability keywords. It would be cool if I had some like sweet name for it, but I'm not a very creative person. That's probably why I like math. It's very linear, black and white. Yes, you're right. No, you're wrong. And I hated English class. Sorry, that was a little off topic. I disliked English so much I challenged out of it in college so that I would never have to write an essay again. All right, so first set of keywords would be words that tell us we're looking at the probability something does not happen. So, does not happen. Or something like, I don't know, like don't. Usually to me, the complement rule is the easiest one to identify that you're using the complement rule, except for that at least idea, which really is using the complement rule, so it kind of falls under this as well. But to me, like I said, the complement rule is the easiest to know that, oh, hey, they told me the probability that this happens is this, and they want me to find the probability it's not going to happen. So in my opinion, this one is the simplest to identify. But those are the keywords that you would look for. Does not happen. What's the probability that I don't draw a black card? Thanks, Chloe, for the boost of confidence that English sucks. Then the word or. So what's the probability that this or that happens? And I'm looking, I know on your homework, either, first of all, or, remember, is that union symbol. And then either is another way to say or, and that word shows up in your homework. So what's the probability of either? That would mean this or that. I'm trying to think of other words that might mean or. Like I said, sorry, I suck at English. So, or, either, anything that would imply this or that. That means you're looking at your addition rules. And there are two addition rules. There is the addition rule for mutually exclusive events, and then there's the general addition rule for any two events. So when you see or, either, anything that might mean or, there are two situations. The two events are mutually exclusive, or the two events are not mutually exclusive. So when you see the question and it tells you that you're working with the or situation, you want to ask yourself, are the two events mutually exclusive, or can they happen at the same time? If they are mutually exclusive, the probability of A or B happening is found by the probability of A plus the probability of B. If they are not mutually exclusive, the probability of A or B comes from the probability of A plus the probability of B minus their overlap. And see, sorry, I went out of my box. And that would be the intersection symbol. In your homework tonight, you'll see both. So what's the probability of both? That would be A and B happening. I'm sure there are other words that would mean and, but and both, those tell us that we're looking at our multiplication rules. And again, there are two situations when it comes to the multiplication rules. You have the general multiplication rule, or you have the multiplication rule for your independent events. So two events are independent, meaning that, and I'm going to abbreviate independent, meaning that the outcome of one has no effect on the other, or the two events are not independent. So if the two events are independent, the probability of A and B happening is bound by the probability of A times the probability of B. If they are not independent, the probability of A and B is bound by the probability of B given A happened times the probability of A. Sorry, my multiplication symbol kind of ran into that parenthesis. And then the last one is our conditional probability. So keywords there would be given. So given a condition, no blank happened. When we were working with the cards, it said something like, "What if the card selected is red? What's the probability that the card is a 6?" So you might see something like, if blank selected, that gives you a condition. I think we also looked at that with the females and the Democrats and the females in the eating breakfast, although I think it was males in eating breakfast. But it said, given that the student selected is male, what's the probability they eat breakfast? So that kind of phrase, the word given, or a phrase like, you know something happened, might see a word like already. So that tells you something has happened. So any of those and probably others would tell us that we're using our conditional probability rule. So the probability that B happens given A happened is found by the probability of A and B divided by the probability of A. So that's my little graphic organizer. I lost my first page. So the complement rule, you would use that when you see words like does not, don't, opposite, I suppose, when you want to find the opposite of something. The addition rule for any two events, that was the word or. What was the other one? Either. I wanted to say neither. I knew that was wrong. And the mutually exclusive events, that was or and either also. Conditional probability, so given, no, something happened. The general multiplication rule, that's and, both. The multiplication rule for independent events, that's also using the words and both. And then just a little reminder, independent events. Independent is when you have two events and the outcome of one doesn't affect the other. And see, this is where I hate English too. I don't know if it's effect or affect. One event, not events. Has no, is it affect or effect? One event has no effect on the outcome of the other. Affect, effect. Don't know. We'll go with E because that seems to be the more common one. One event has no effect on the outcome of the other. So I guess up here we could also add that one event affects the outcome of the other, and so we need to use this rule. And then the at least one rule, that's if you see the word at least one. At least one. Any questions about any of the rules, clarifying any of what I said today? No?
Could you go back to the graphic organizer? Can you also go back to the one before that after?
Yeah. Are you good, Bailey?